Good morning, everyone. Welcome to my presentation. So this is my topic: modeling rainfall-induced slope failure using SPH with an advanced unsaturated soil acoustic model. So as you may know, rainfall-induced landslide is one of the most common serious natural hazards for hilly slopes due to prolonged or heavy rainfalls. It may suddenly occur with high traveling speed, posing threats to human life and properties. So, for us, like economy or geotechnical engineer, what can we do to minimize this problem? So, among various methods, the early warning system is considered one of the most promising ways. And in this early warning system, it requires a model that can predict when, how, where that this disaster occurs. And then that is what we did. So first, we go through several methodology. We start from an RVE of unsaturated porous media, including of solid, water, and air. And then we apply the mixture theory to establish the governing equation for each homogenization phase. And then after that, we're using the single layer approach. That's where we combine every other governing equation and establish a unique governing equation for entire system, including porosity change, seabed flow, and the motion equation. And when we want to solving this equation, we need several components. First is unsaturated quantity model. That's where we want to describe the soil change behavior change when the rainfall happens. The second thing here we're using is the soil water curve and water Hermite function. Basically, it demonstrates that how the rainfall infiltrates into slope. Is it the water flow fast or slow? And finally, to solving the equation, we need to solving the spatial derivative. That's where we're using the numerical method. So in here we're using the SPH method. So SPH method is the continuum mesh-free method in which particles carry field variables and move with material velocity. And after we complete the framework, in addition, we also develop the ground modeling. Basically, because in reality, we often see some limited data, example like some of the borehole, and we develop the optimization algorithm to basically reconstruct the soil profile to do the simulation. So this is one of our our framework, the field scale prediction. So in this year, we verify again of the field experiment of Ascarin Nether 2009. And in this experiment, they had some sensor in the slope, and also after the test, they also recorded the failure area. And here is our simulation. So as you can see on the bottom of this animation, you can see that how the rainfall infiltrates the slope, the water accumulated, and the failure area is also observed similar with the experiment automatically. On the top, that you can see that the pore water pressure evolution compared between our simulation HVH with the experimental data. The result is captured quite nice, and when you see the displacement evolution, you can see that we were able to capture which is the stable stage or the collapse stage, and from there that we can use the information to do the early warning to have the people evacuate our dangerous situation. And not only 2D, we also in 3D, which will be sent in the poster presentation, and then we can also apply for the view application. Thank you.
Thank you, John. Okay, question?
Excellent. I really loved it. Can you just say something about the interaction forces in your multi-phase SPA, three phases, and then there is interaction forces. How do you get those interactions between the phases? Do you know?
Yeah. So basically, when we solving the governing equation, we get some of the several of the seabed flow. So the interaction here is if we apply the rainfall condition, and the rainfall will change the pore water pressure, and this pore water pressure will change the shear strength of the soil, and from that is giving the motion of the particle of the soil. So that is how the framework works.
Thank you, Ty. Again.